Welcome back to JVM Internals Crashcasts. I'm Sheila, and with me as always is our JVM expert, Victor. Today we're diving deeper into the world of JIT compilation, specifically focusing on tiered compilation. For those new to our show, JVM stands for Java Virtual Machine, the engine that runs Java programs. Victor, are you ready to unravel this fascinating topic?
Absolutely, Sheila. I'm excited to explore tiered compilation with our listeners. It's a crucial optimization technique in modern JVMs that significantly impacts performance.
Great. Before we dive in, let's set the stage for our listeners. We're currently in Level 2 of our series, JVM Adept, where we're exploring operational understanding of the JVM. In our previous episode, we discussed the basics of JIT compilation and how it differs from interpretation. Today we're taking it up a notch with tiered compilation. But first, let's start with a quiz question for our listeners. In a JVM using tiered compilation, which typically consumes more CPU time, the compilation process, or the actual execution of the compiled code?
That's an intriguing question, Sheila. It really makes you think about the trade-offs between compilation time and runtime performance. I'm curious to see what our listeners think. Without giving away the answer, I'd say it's not as straightforward as it might seem at first glance.
Indeed, Victor. It's a question that touches on the very essence of why tiered compilation exists. Now, before we delve into the details, could you give us a quick refresher on JIT compilation and why we need tiered compilation in the first place?
Certainly. JIT compilation, or just-in-time compilation, is a technique used by the JVM to convert bytecode into native machine code at runtime. This allows for better performance compared to pure interpretation. Tiered compilation is an enhancement to this process, designed to provide a balance between quick startup and optimal long-term performance. Think of tiered compilation like cooking methods in a busy restaurant. You might start with a quick microwave for immediate serving, then move to a stovetop for better quality, and finally use a slow cooker for the best flavor, all depending on how long you have and how many times a dish is ordered.
That's a great analogy, Victor. So, tiered compilation is like having multiple cooking methods available, each with its own trade-offs between speed and quality. Could you explain how this works in the context of the JVM?
Absolutely. In the JVM, tiered compilation typically involves multiple levels of compilation, usually implemented with two different JIT compilers, C1 and C2. C1, also known as the client compiler, is designed for quick compilation and basic optimizations. It's like our microwave in the cooking analogy, fast but not producing the most optimized code. C2, the server compiler, performs more aggressive optimizations but takes longer to compile. It's like our slow cooker. It takes more time but produces highly optimized code.
I see. So how does the JVM decide which compiler to use and when?
Great question. The JVM uses a combination of interpretation and these different compilation levels, moving code through them based on how often it's executed. This process typically involves several tiers. 1. Interpretation. The code is initially interpreted. 2. C1 compilation with no profiling. Quick compilation for frequently used methods. 3. C1 compilation with light profiling. Adds basic performance data collection. 4. C1 compilation with full profiling. More detailed performance data is gathered. 5. C2 compilation. The most aggressive optimizations are applied. The JVM starts by interpreting the code. As a method is called more frequently, it progresses through these tiers, collecting more profile data and applying more optimizations along the way.
That's fascinating. It sounds like the JVM is constantly analyzing and adjusting its compilation strategy. What are the main benefits of this approach?
The primary benefits are improved startup time and better overall performance. By using the faster C1 compiler initially, the JVM can quickly compile frequently used methods, improving performance over interpretation without the delay of full optimization. As the application runs longer, more methods can be optimized by C2, leading to better long-term performance. This approach is particularly beneficial for long-running server applications, which have time to warm up and take full advantage of C2's optimizations.
I can see how that would be advantageous. Are there any drawbacks or challenges with tiered compilation?
Good point, Sheila. While tiered compilation offers significant benefits, it's not without challenges. One potential drawback is increased memory usage, as the JVM needs to store multiple versions of compiled methods. Another challenge is determining the right thresholds for moving methods between tiers. If these thresholds are too low, the JVM might waste time compiling methods that aren't used often. If they're too high, it might miss optimization opportunities.
That makes sense. It sounds like there's a delicate balance to strike. How do real-world applications benefit from tiered compilation?
In practice, tiered compilation can have a substantial impact. For example, one large-scale study found that enabling tiered compilation reduced startup time by up to 30% and improved peak performance by up to 20% compared to using only the C2 compiler. However, it's worth noting that the exact benefits can vary depending on the nature of the application. Short-lived applications might not see as much benefit from the higher compilation tiers, while long-running server applications can really leverage the full potential of tiered compilation.
That's impressive. Now, I think it's time we revealed the answer to our quiz question. Victor, would you like to do the honors?
Certainly. The question was about whether compilation or execution typically consumes more CPU time in a JVM using tiered compilation. The answer is that in most cases, the actual execution of the compiled code consumes far more CPU time than the compilation process. While tiered compilation does involve multiple compilation steps, these are typically a small fraction of the overall runtime for long-running applications. The goal of tiered compilation is to minimize the impact of compilation on runtime performance while maximizing the benefits of optimized code execution.
Thank you, Victor. To summarize today's episode. 1. Tiered compilation is an enhancement to JIT compilation that balances quick startup with optimal long-term performance. 2. It typically involves multiple levels of compilation, using both a quick, lightly optimizing compiler, C1, and a slower, heavily optimizing compiler, C2. 3. Code progresses through different compilation tiers based on how frequently it's executed. 4. The main benefits are improved startup time and better overall performance, especially for long-running applications. 5. Challenges include increased memory usage and the need to carefully tune compilation thresholds. In our next episode, we'll be exploring optimizations in JIT compilation, such as inlining and loop unrolling. Don't miss it.
Excellent summary, Sheila. I'm looking forward to diving into those optimization techniques in our next session.
Thank you, Victor, and thank you to all our listeners for tuning in. If you're enjoying our deep dives into JVM internals, please subscribe to JVM Internals Crashcasts and leave us a rating. Your support helps us continue creating this content. Until next time, happy coding.